So this is page 5. This first problem is kind of a big problem. It's dividing complex numbers. So to get that I out of the denominator, which is what we need to do, the directions say that they want the answer in a plus bi form. So you only get to have one I, and a and b have to be real numbers. So we're going to multiply by what's called the conjugate or the complex conjugate, which is 4 plus I. It creates the difference of squares in the denominator, but I'll show you how that all works out. So if I were to multiply out the numerator with FOIL, we already did a problem like that, but 20, 5 times 4 is 20, and then you get 5i, and then you get 8i, the 2i times the 4, and then the 2i times the I is going to be plus 2i squared. I always just write it out that way, and then I fix it later on. Okay, in the denominator, you don't have to do the O and I. You can. A lot of times students do. 4 times 4 is 16. And then maybe just out of habit, here's the 4i, and here's the minus 4i. We know those are going to cancel out. And then you're going to get minus I squared. So that's important, all those symbols, and you can just FOIL it. It's easy to remember FOIL generally. Or you might have another way that you multiply. But if you write it all out, that, when in doubt, write it out. Okay, so this 2i squared is going to become a negative 2. And so if I want to save myself a little time, I can think 20 and negative 2 is 18. And then right here, that's a plus 13i. Okay, that's the numerator. Now I've got a 16. And then the 4i and the minus 4i cancel. And that negative I squared is going to become a plus 1. Okay, so I didn't do it the same way on the top and bottom. I should have, but that would have made it a little easier. But now 16 plus 1, that's going to be 17. So you have 18 plus 13i over 17. But to write it in that a plus bi form, you're supposed to split them up. So 18 over 17 plus 13 over 17. And that's what you get. My rectangular television is 32 inches wide and 57 inches long. I actually measured it. And so it's 32 inches here and 57 inches here. I'm sure I rounded it off. Okay. How long is the diagonal of the television? So the diagonal is like right here. That's how they measure TV screens. And round answer to the nearest 1/10 of an inch. So we're trying to find this distance here. This is a right triangle, and so we're going to use the Pythagorean theorem, which says a squared plus b squared equals c squared. And a and b are the two sides, so this is like a, and this is like b. It doesn't really matter which one you make which. So you get 32 squared plus 57 squared equals c squared. And I think I just put it all in a calculator, so I don't have the actual numbers for you, but it wound up being 65.4 inches. Now that is a linear measurement. It is not a square measurement. So you're going to figure out what this number is. You just put that in the calculator, and then you're going to have to take the square root of that. Okay, so you're doing the square root of whatever 32 squared plus 57 squared is. Depending on your calculator, you can put this all in at once for most calculators, but you might want to do it in 2 steps. Okay, but that's the answer. And then I think we have one more problem on this page. So you have an equation, you're trying to solve for x, but you have a radical, a square root in there. So to get rid of the square root, you're going to square both sides. So that gives you 20 minus 8x. The square root and the square, those are inverse functions, so they're gone. You just have 20 minus x, and then that equals x squared. Now, this is a quadratic equation, so we're going to set it to 0, and we're going to move the 8x to the, it's negative, but we're going to move it to the other side. It'll be positive, and then the 20 is going to come over, and it's going to be minus 20. Now, you can solve this quadratic equation. We did that earlier in earlier problems. You could factor, you could use square, you could complete the square, you could use the formula, but if it factors, it's almost always easier to factor, and this does factor. So think of two numbers that multiply to be negative 20, maybe 2 and 10, but we need one of them negative, don't we? Negative on the 2. Okay, so x minus 2 and x plus 10. And so this gives us two answers by the zero product principle. This could be 0, so x could be 2. Or this could be 0, x equals negative 10. Now, some of you got there and stopped. Unfortunately, when you square both sides or you raise both sides of an equation to an even power, you have to check the answers because you could have created an extraneous root. Okay? So we have to check. Here comes the check. Yeah, I have to see the check. If you didn't write out the work, I would have taken points off for that. Okay, so the original equation is minus 20. I'm sorry, square root of 20 minus x equals x. That's the original. So we're going to put in 2 and see if it works. Square root of 20 minus 8 times 2. Does that, in fact, equal 2? So I'm trying the 2 to see if it works. Square root of 20 minus 16, square root of 4, square root of 4 is 2. Yep, it works. Smiley face on the 2. So that one works. Now, maybe the negative 10 works, maybe it doesn't. We don't have any guarantees. So we go back to the original. 20 minus 8 times negative 10. Does that equal negative 10? Well, you might have a suspicion here. So 20, square root of 20 plus 80, because negative 8 times negative 10 would be 80. Does that equal negative 10? 20 and 80 is 100. Square root of 100 is 10, but not negative 10, so no. That one doesn't work. So somehow I need to see that you went through that thinking process so that I know you know why the answer is what it is. Okay, so we get x equals 2, and we can put a box around that or something like that. Okay, that was the last problem.